Okay, so we're gonna resolve this circuit. Now the idea is to get it down to one single resistor first. Add all the resistances together and find the total resistance for the circuit, and then we're gonna work our way backwards to find the voltage drop and the current through each of these things. Now, some information we'll need. This right here, it's called Ohm's law, and it's the way we can calculate voltage and current and resistance if we have two of them. Okay, when we use the circle, whatever you need, you cover up, and what's left is your formula. So if I need I, which is my current, I'm covering it up, and I'm left with a voltage divided by resistance. And if I need a voltage, I would cover that, and I'm left with a current times a resistance. Okay. When I add resistances together, if they're in series, I'm going to simply add them together. If they're in parallel, I'm going to add them together with reciprocals. Now, on a calculator, there's just a button for that, so I'll show you how to use that when we get to one as we go. And then when we go to work back, you need to note that for a series circuit, all the resistors are going to have the same current, the same amount will flow through each of them, and for a parallel circuit, all of the resistors are going to have the same voltage drop. So if we split a resistor into two series resistors, we will keep that same current that we had before we split it, and we'll have to calculate a new voltage. And if we split a resistor into two parallel, we will keep the same voltage and we'll calculate a new current. Okay, so I've drawn them all. You need to draw the picture every single time as you put resistors together, or you will not be able to go backwards and find your answers. So the first two I put together, okay, is this 75 and this 95. The current has to go through one and then through the other, which makes this right here a series circuit. So I'm simply going to add together 75 plus 95 and get 170. So I know that this is 170 ohms, and everything else stays the same. Okay. And I'm not going to write all of them in just for the sake of, yeah, actually I will, but okay. So the next two that I was going to put together is this 110 and the 180. Now those are two parallel circuits. Now you'll notice that they are not literally geometrically parallel to one another, because that's not what that means. When the current splits, comes up to a point, and it has a choice to go through one or the other, okay, and then it all comes back together here, that's a parallel circuit. Okay. In order for me to put them together, they have to be simply one resistor on each of those loops. So it can either go through this one resistor or this one resistor, and then all comes right back together here. Okay, when I add them together with this funny reciprocal formula, what I do is I'm going to push 110, and then I'm going to push this 1 over x, okay, plus the 180, and we'll push the 1 over x again, equals, and we're going to push it one more time, and that gives me 68.3. We're going to round a little. We expect the total resistance for a parallel circuit to be less and the total resistance for a series circuit to be more. Okay, and we'll keep all of these. Okay, now I've got these three right here. Okay, all of the current has to go through one, and then the next, and then the third, which means I can just add all three of those together, and I'm going to leave this 68 in my calculator, plus 170 plus 250, okay, will give me a total of 488.3 ohms. Okay, and my 180 didn't change. Okay. Now I'm left with these two that are in parallel. So we're going to take this. We have our number. Oh, where'd it go? 1 over x plus 180 1 over x equals, one more time. Okay, and we get a total resistance of 131.5 ohms. Okay. Just a quick note here, if you have a Casio calculator, that 1 over x button instead says x to the negative 1. It's written right here. So like these first two, I would go 110 and then push it, plus 180, push it again, equals. We'll push that after the answer, but you have to push equals to get to that 68. Basically, TI like this is the same. That button is right here above the 7. Okay. Okay, so now working our way backwards. Okay, now I have the current. The voltage drop across this resistor is the voltage that's in the circuit. So it was a 120 volt circuit, so I have 120 volts current drop right there. Okay, now I need to find the current. Okay, again, here, we'll screw that up. I need current. Current's the I cover it up. I'm left with a voltage divided by resistance. Okay, so I have 120 divided by 131.5. Okay, and you will get a resistance here of 0.913. Excuse me, a current, 0.913 amps. Current is usually going to be really, really, really little, so don't worry when this number comes out to be something with like 0.00 something. Okay, it's going to be very, very small. Okay, so from here, I work my way backwards. So I essentially take this 131.5 and I split it back into these two that I got it from. This was parallel, so if you come back up here and remember, okay, in a parallel circuit, we keep the same voltage, but we're going to need to calculate a new current through those. Okay, so the voltage drop across each of these is 120 volts. Okay, and we calculate a new current. Again, current is voltage over resistance. Okay, so here it will be 0.246 amps, and here it will be 0.67 amps. Okay. Since this 180 doesn't change the whole way through, I'm just going to come back here and write that this is 0.67 amps and 120 volts, and I no longer have to worry about that resistor. Okay, when I split this one here, so I go from this one resistor to these 3 resistors in series. Okay, so we come up here for a series circuit. I keep the same current, but I'm going to need to calculate a new voltage drop across each of those. So my current for each of these is going to be 0.246 amps. Okay, and we'll go through and find a new voltage. And again, voltage covered up is a current times a resistance. Okay. So 170 times 0.246 is 41.8, and 250 times 0.246 is 61.5, and then 68.3 times 0.246 is 16.8 units, volts each time. Okay. Again, the 250 never changes, so we'll put that in. 0.246 amps and 61.5 volts. Okay, so I've taken care of that. From here,